Hi, another video about mechanics. So it says two small blocks of mass 1.6 and 1.8 are attached with a light inextensible rod which is parallel to the base of the blocks. The blocks are placed on the plane inclined at 30 degrees to the horizontal, with the 1.6 kilogram block higher than the 1.2 kilogram block. The coefficient of friction between the 1.2 kilogram mass and the plane is 0.6, and between the 1.6 kilogram mass and the plane is 0.4. We're asked to determine the acceleration of the system and determine the magnitude of the force in the rod, stating whether it's in tension or compression. Okay, so we're going to assume that the thing will try to slide down the slope. So we're going to draw a force diagram, which is always a good step in a mechanics problem. So, drawing the diagram, we have the weight of the 1.2 kilogram block, which is 1.2 G newtons. We have its normal reaction here, which we're going to call R1. We have a tension in the rod acting up the slope, and we have a frictional force as it's tending to move downwards, which we'll call F1. For the 1.6 kilogram block, we have a weight acting down at 1.6 G newtons. We have its normal reaction, which we'll have to call R2, and we will have a tension which will be acting down the block here, and we have an F2, a frictional force acting up the slope. Okay, so if we now resolve perpendicular to the plane, right, we're going to resolve this way. We have, for this block, we have R1. And then if we draw in the components here, we have this little triangle here. This angle here will be the same as this one here with 30. And therefore this length here will be 1.2 G cos 30. We have take away, that will be equal to 0 because it's in equilibrium. And then we do, from that we can say that R1 will be 1.2 G cos 30 degrees. We know the coefficient of friction between this block and the slope will be 0.6. So therefore, using F1 is mu1 R1, we can say that that's going to be 0.6 times 1.2 G cos 30. Doing a similar thing for this block here, the 1.6 kilogram block, we're going to have R2 acting upwards positively, and then we're going to have this one here, same idea, which will be 1.6 G cos 30 degrees, and that will be equal to 0, which will give that R2 is 1.6 cos 30, and then we know that mu2 is 0.4, and therefore using F2 is equal to mu2 times R2, we're going to get 0.4 times 1.6 G cos 30 degrees. We'll come back to these two equations later. Okay, so we'll now add an acceleration to the system. So the acceleration is going to go that way. We'll call it A meters per second. And then we will say that resolving along the plane, they're going to resolve this way now. We'll take each block separately. So the 1.2 kilogram block, we're going to have, again, using components, this one here will be this component here, which will be 1.2 G sine, because it's opposite the angle. That's the weight of that block, that component. We're going to have to take away the tension and the frictional force, and it'll be moving according to Newton's second law, so it'll be 1.2 times A, which we'll call equation 1. And then for the 1.6 kilogram block, we're going to have T, this force acting downwards, plus the weight, which is going to be 1.6 G sine 30, using the idea of components here. Take away F2, and that will be equal to 1.6 A, according to Newton's second law. If we add these two equations, that will eliminate T, so we'll get 1.2 G sine 30 plus 1.6 G sine 30, which is 2.8 sine 30. The T's will be eliminated, and then we'll just take away F1, F2, and that will be equal to 2.8A. A will be 2.8 G sine 30 minus F1 minus F2 over 2.8. So write that down again. so we can see what we're doing. Okay, so we know that F1 was equal from before, and then if we just simplify that, we get 0.72g cos 30, and therefore F2 will be equal to this from before. That will give me 0.64g cos 30 degrees, and therefore A will be equal to 2.8g sin 30 minus 0.72g cos 30 minus 0.64g cos 30 divided by 2.8. Getting our calculator out, use the fraction button on the calculator, make sure your calculator is in degrees. That will give you an acceleration of 0.777. And then obviously we round that off to three significant figures, we get 0.778 and put the units in meters per second squared. Now, we will use this value though in any further calculation. So for part B, we'll substitute into equation 2. So equation 2 was this, t plus 1.6g sin 30 minus f2 is equal to 1.6a. So we're going to get t is equal to 1.6 times a minus 1.6g sin 30 plus f2. So basically we're taking these two things to the other side. And that will give me 1.6 times the answer, not rounded off. So use the answer button on your calculator, provided you've not done any further calculation, plus 1.6g sin 30 plus 0.64g cos 30 for F2 from here. Okay, and then on my calculator, that will give me minus 1.1637. So this means because it's negative, the force in the rod is minus 1.64 newtons, and as it's negative, that means the rod is in compression. Now, to go in this video, in the notes of this video, there will be a GeoGebra app, which looks like this. So, and this is the situation that we've just calculated, but we can actually change things here. For example, if we made the frictional coefficient higher on this one, you can see the frictional force getting bigger, then obviously there'll be no acceleration, and then obviously the force will go into tension, and you can change some of the other variables as well. You can change the masses here as well. So I'll leave you to explore this app. You can also even change the angles, okay, and make it different angles. I hope you've found this video useful. And this GeoGebra app will be in the notes of the video, plus links to all my other video resources, where I literally have thousands of videos put on A-level maths. And I thank you very much for watching.